At the start of a series of tests, always balance the force of the load cell. Thus, zeroing the load cell and any forces applied will be displayed from the 0 point. Slight fluctuations, a fraction of a newton, are indicated on screen, and this is because the load cell is very sensitive. Any movement within the lab or surrounding areas will be noted by that figure. If the figure on screen was perfectly still, that would be cause for concern, perhaps an issue with the load cell. Add the preload to the specimen somewhere between 600 and 1000 newtons by depressing the rocker switch upwards, or just a flick of the switch. Meanwhile, attention is on the screen to observe the force. Give the machine a moment to register each tap. Two newtons. Once it's gripped the specimen, it's jumped to over 300 newtons, and that's just under 1000 newtons at 992 newtons. At this point, zero the position of the crosshead, that's the displacement, and press on the zero displacement icon. Any movement now will be measured from this point. Onto the next screen, and here type in the name of the specimen. In this case, it's aluminium and its date, meaning how it was manufactured. The state of this specimen was cold drawn, or referred to as cold worked. Next, the rate of extension, that is the same for all the specimens, 3 millimeters per minute. Scrolling up, the length, that's the gauge length. This is approximately an inch, which is 25 millimeters. It doesn't need to be exact for the software. On the next parameter is the diameter. It's the average diameter figure that was calculated from the 4 measurements. In this case, for aluminium, it was 5.06 millimeters, and enter. Close the keyboard. Check everything is as it should be in terms of the parameters that have been inputted. Also ensure that the safety screen is closed. Once ready, begin the test by pressing on the Start button. A graph is plotted. Maximize it. Note the plot of force against displacement is in live time. This initial linear line can be observed. It is referred to as the line of modulus. The curvature here indicates the specimen is entering permanent deformation, the plastic region. The area under the graph before that curvature takes place is referred to as the elastic region. If the machine is stopped and removed anywhere before that initial curvature point, the specimen would return to its original shape and size. The force is dropping. For metals, this indicates the specimen is heading towards failure at just under 5,000 newtons of force. The aluminium indicates it shall soon completely fracture. The machine will stop automatically at point of fracture. Press on stop as a precautionary safety step. On screen, tap on the icon Results, then tap on Calculating. This displays the maximum load, Fmax, 5,945.38 newtons. This figure is used to calculate the tensile strength. Tap back to the graph, which now displays two triangular-shaped points. These are located by the software. This one indicates the yield point, and the second indicates maximum force, the latter already noted on the results screen. To calculate the yield strength, zoom in onto the first triangle along the plot. Locate the circular shape over the triangle by tapping onto it, which will then indicate the location point on the y-axis corresponding to 4,510.55 newtons. Hence, force at yield, or Fy, is 4,510.55 newtons. Before testing the next specimen, press and hold on the screen, or to scale to show the whole plot, and tap to Before Test. This process will be repeated for all the specimens. Once a specimen has fractured, it needs to be retrieved from the machine and then have the next specimen inserted. For retrieval, open the safety screen and in reverse order take out the specimen. Ensure not to catch fingers and hands on the fractured ends here, which are sharp, enough to cut and draw blood. So move the crosshead up and out of the way using the rocker switch, pressing up and hold. Ensure there's plenty of space between the two halves for hands to get in there. The other reason not to touch the fractured face is so to not break off any jagged protrusions from the fractures. If any part breaks off, when placing the two halves back together in the tensometer elongation gauge, some of the length achieved may be lost. Starting from the top, hold the collet in one hand, remove the locating pin with the other, and retrieve the collet. One of the broken specimen halves will be in here, and place it to one side. Then retrieve the second half of the specimen. Remove the pin here. Lower the collet. Using two hands, lift the two halves up and out of the way, placing them on the bench. Then retrieve the other half of the specimen. To insert the next specimen, repeat the earlier steps with the new material.